Hello, my name is Ahmed Osama, and I'm here to talk about our DSD project. The main idea of the project was to implement a smart chessboard that would feel how the pieces would move, and it could pass it on to the logic of the game, so it could be implemented on a physical board instead of the computer. Um, about the top level module, it is used to combine all the down level modules. It takes the inputs from the sensors, the signals are passed to the Altera by multiplexers. There are 64 sensors, and there aren't enough pins in the Altera, so we had to use multiplexers to give the input as serial. So here's the tester module used to check for if the sensors work. Here are these three switches are the selects for the multiplexers. It takes D0 as input. This column represents the D0 selection from the multiplexers. If I move this piece, the LEDs change. There are 4 missing sensors here, so they aren't working. If I go to D3, it will also see the piece moving. If I go to D4, also see the piece. So that's basically the idea, and that's these are the testers. These basic ideas could be used to pass the inputs and the output, the inputs to the Altera, and the previous state could be it could be used two 64-bit registers, the previous state register and the current state register to know what piece moved and implement the logic on the piece on the whole board, so the whole logic could be manipulated.
Hi, my name is Ramza Hassan, and I will be talking about implementing the hardware board. Here we have 4 boards. We have the FPGA board and 2 breadboards and a wooden chessboard. The wooden chessboard is connected to a 64 magnetic sensor. Each magnetic sensor is connected to 3 wires, a ground, and a voltage, and a signal. And these wires are connected to the 2 breadboards. And my colleague here is going to talk about the implementation of the wires, and through these wires and through these chess wooden boards, we manipulated all the chess game, and we manipulated the previous and the current state and everything through these wires.
So now I'll be talking about the connection between the 4 boards that we talked about, and how the sensors are related to the magnets, and how the wires out of the sensors are related to the 4 boards. Each sensor on the chess wooden board has 3 input wires. The 3 wires are the earth one, the voltage one, and the signal one. The earth and the voltage one are connected to the first breadboard here, and the second and the signal one is connected to the second breadboard. This breadboard contains 8 multiplexers, 8 by 1, and the 64 wires coming out from the 64 sensors are connected to the 8 multiplexers here. The one very output is connected from here, the breadboard, to the 8 pins assigned here in the Altera FPGA board. As for the software part of the project, we implemented 3 sub-modules that are called in the top-level module. The first module is called count. The count module simply does the following. It outputs a phased output, which is incremented at every clock cycle, meaning that at the first clock cycle, it outputs 0, second clock cycle, it outputs 1, and so on, until it reaches 7. It outputs from 0 to 7 on 7 consecutive clock cycles. This module is used as the select for the multiplexer, so that the multiplexer can output 1 signal at a time. The multiplexer is used
8 signal inputs. There are signals coming from the center. Each center is output as assigned in order, meaning that the signal from center 1 is output at the first clock cycle, then the signal from center 2, then the signal from center 3, and so on. So the multiplexer can output the 8 signals coming in order and in only 8 clock cycles. And the other module is to control the state of the chessboard, meaning that the module receives as an input two 64-bit registers. The first 64-bit register represents the current state. The second one represents the previous state. And it outputs to also two 64-bit registers representing the piece that was changed, where from and where to. The module works as follows. It takes the input and loops over the every bit inside the input. It checks with the same index in the two registers which piece has changed value, meaning that if a piece has value of 0 in the previous state and now in the current state it has the value of 1, this means that this place had no piece in the previous state and now it has a piece. This means also that a piece has been moved to this location. So we take this location as the true location. As for the from location, we detect the location where it was equal to 1 in the previous state and it's equal to 0 in the current state, which means that it had a piece and then it was removed. So we calculate or we implement the from location and the to location. The output of this module is sent to another module that displays on the 7-signal display the index of these two locations.